In this video, we're going to graph a piecewise function and state the domain and range of it. So let's do that. Now, a piecewise function, you have to look at it literally like three separate functions. And if they connect, they connect. They don't have to. But let's just look at it like that. So for all the values less than -2 on the x-axis, that is, we are going to make y -1. So -1 is right here, and I'm going to put an open circle right here. This is open. It's not closed. There's a little space there because it's all the way up until -2, but not including 2 itself. And it's always -1. So here is an arrow just going off in that direction. We'll make it a little bit thicker. All right, so that's just a line showing that y is always -1 when x is less than -2. Now, between -2 and 2, right? So between, let's use a different color for this. So between -2 and +2, right? Between here and here, we have 2x plus 1, right? We have y equal 2x plus 1. Well, this just means, well, no, I wrote that incorrectly. Not 2x plus 1, it's 2 plus x. That's a completely different function. 2 plus x. I'm going to rewrite it in a form that you may like. That's when the x is in the front. Right? And since that's a +2, put it back there. So why did I do this? So I can see the slope. The slope is 1/1, and the y-intercept is 2. So my y-intercept is 2, and the slope is up 1/1. Up 1/1. Now, I'm not going to put a solid dot there. I'm going to put an open circle. Right? It does not include the point at that very x value of 2 because it doesn't have the little equal sign underneath it. All right, and the same thing going backwards. So just follow the slope going backwards. Down 1, back 1. Down 1, back 1. But there's an open circle at -2. It does not actually include those values. Let's erase these little lines, these guidelines that I made. I'll just connect them. All right, I know it's a little bit thin. I should make this line thicker, but that's okay. So that's this piece. Now let's graph the other part. Now this one does have a point on 2, so at 2 I'm going to make a solid point. Now we want to graph the function. Let's use a different color. Let's use red. Y equal x square. All right, so I'm just going to make a little x and y table. Let's do it old school. We're starting from 2, and we're moving on up. So we're now going backwards. So 2, let's get some points. So 3, 4, let's do 5 as well. All right, so if x is 2, then y would be 2 squared, which is just 4. If x is 3, 3 squared is 9, 4 squared is 16. And we don't even need that because this is off the graph, right? But this would have been 25. So when x is 2, y is exactly 4, which is the same spot. So I'm just going to fill that in. 3 is 9, which is all the way here, and I can't even graph 4. Hold on, is this going by 1, 2, 3, 4? Okay, this is 4. Well, 4 is like 16, which is like really high up. So what we're going to do is just draw a line and draw an arrow continuing off in that space, right? It goes off to infinity. All right, so state the domain and range of f of x. So f of x is the entire function, right? Even though it's in pieces, we want the entire domain and range. Okay, so the domain is your x value. I didn't realize I used red here and here. That's okay. So the domain is your x's. So let's see. So domain. So your domain is starting, when you're writing the domain, you need to put it from the lowest value to the highest value. It must be in that order. And I'm going to use interval notation. So it's all the values from -infinity, which is like all the way back there, all the way up to -2. does not include that value of negative 2. So we're going to put a parentheses, and we're going to put this union, and we're going to write the other set. So it does not include that value of negative 2. So again, we start back at negative 2. So notice, this is literally just skipping the value of negative 2 itself. It goes all the way up to negative 2. All the values up until negative 2, like negative 1.99999, but not negative 2 itself. And same thing here. Actually, this will be negative 2.000001. Anyway, so it starts at negative 2 and it goes all the way up to 2. Now, I am not thinking about it as a separate thing because it's connected. We do have a value at 2 for this other piece here, so I don't need to like write a certain set for this. I could just continue, right? The only thing I had to do was represent this little difference right here, this missing negative 2. So it's from negative 2 all the way to infinity, because there's a value all the way at 2. There's a value here. There's a value all the way at 8. There's a value at 9. There's a value at 10. It's like all the way high up, but it just keeps on going to infinity. So this is the domain. The range is when you look at the y values now. So I'm looking at the y values. And again, we're going to do the same way. I thought I chose a different color, but that's okay again. Now the lowest y value is negative 1, right? And we do have a value itself at negative 1 because there are points on this line. So negative 1. And we skip. There's nothing from negative 1 to 0. There's nothing within here. No part of the function is there. So we're just going to say negative 1. I'm going to make that a parentheses. Union. Oh, it's equal to negative 1. So I'm going to put that in a bracket. Right? Negative 1, union. Now it starts up from 0, not including 0 itself. So that's why we have this parentheses, 0. And it goes all the way up to infinity and beyond. So that's the range in interval notation. I have to be honest, I've never actually written an interval where it was just like a single thing in there and then it's union with something else. So this is a little bit strange for me, but overall I'm still confident with how I wrote that.